Yes, welcome back to CMG-MathSpace. We were dealing with significant figures, right? We started with the first episode. We told you it will probably end in two parts. Of course, we are here because of the time on our side. So we got to this particular point, rounding 742,394. Oh, what is this? Rounding 742,396 to 4 decimal a significant figure, 3, 2, and so on. So we got to this particular, the first one, we have 742,400, right? That's 742,400. Why did we get this? Because we are running to 4 significant figures. And we said that we start from the right of non-zero of the figure, right? Non-zero digits of the figure from the left. So 7 is non-zero, so we start from 7. Now 7, that's 1, 2, 3, 4. So 4 significant figure will be on 3. Checking the digit after 3 is 9. Is this 9 greater than, less than, or equal to 5? This is greater than what? 5. So what do? We come back to the original significant figure and add 1 to it, which will make it 4. So now we have 742,400. Why do we bring this 0? There's this rule here that always check that your approximated number is of the same order of size as the original number, right? So probably you may think that, why don't you keep it at 742, then 4? That would be like 7,442. That's 7,424. And that is will not be equal to what? The 700,000 figure that we have. So that is the idea. Because if you keep it here, then we have only 7,000. But meanwhile, we have 700,000, right? Meanwhile, we have 700,000 as the whole figure. So I hope you got it. You are not confused. Now let's move to the 3 significant figure. This 3 significant figure, we have 742. We are dealing with 3. So 2 is the third significant figure. Now, check the next digit, which is 3. Is this less than or equal to 5? This is less than 5. So we will keep that, right? So we keep it 742, right? So the 2 is there. We don't add anything. So the rest of it will be 0. That's what it means. If you got the first understanding, it should be easy for you for the second one. Let's move to the second one. We have 74. There's 2 second significant figure will be 4. This 4, check the next digit, which is 2. Is 2 less than or equal to 5 or greater than 5? It's less than 5. So what do we have? We have 74, right? 74, 0. So we have 740,000, and that is it. So this is as simple as that, because we are making sure that we have the same order as the original number. If we keep it the other way around, the number will be shortened and the answer will be wrong. So in objectives, this is what they will use to confuse you. They will bring the whole figure like this, and then they will truncate it, which is the wrong answer. The cases where you have to truncate is when maybe decimals are involved. These are whole numbers. These are whole numbers, right? So let's move on to the next. Now, let's get things a bit interesting, right? So the first one was whole numbers, right? Where there's no decimals places in the figure, in the original figure. Here we have decimals in the original figure. So let's see what happens here. So here you have been given that around 0.07284 to 4 significant figure, 3 and 2. Now this is what we have. So we were told among the rules that we should start from the left with non-zero digits. So if you are 0 and you are starting with the figure, you are not considered. So counting, looking for the 4th or the 4th significant figure will be from what? The 7. Means that 0, this 0 is not part, second 0 is not part, starting from non-zero digits. So 7. Now 4 decimal places. So 4 significant figures, sorry. 1, 2, 3, and 4. So that's the last figure. So there's nothing there. So what do? Wait. This should be the figure rather. Right. So 1, 2, 3, 4. That is it. There's nothing to change. There's nothing, no extra digit after 4. So it means that the original number is the same as the fourth significant figure, right? With that understood, let's move to the third significant figure. Now we have 1 still here, 7, 2, moving to what? The third significant figure, 8. So 8 is the third significant figure. Now look after the 8. The next digit is 4. Is this 4 less than or equal to 5 or whatever? It's less than 5. So we keep this, right? We keep this, right? So here we are not considering anything because 8 was the last thing to consider, and then after that there's nothing. It's less than 5. So the one that we add or we check, we don't consider it, and this is the decimal form. So we don't check this because this is what we are used to check. Either it's less than 5 or greater than 5. So it doesn't matter to us here. That is it. And then besides, this is a decimal figure. Right. Now let's move to the second one. The third significant figure. Here, 1, 2, 3. Right. So 3 after that. Okay, I think we have done that. Now moving to the 2 significant figure. 7, 2. This is 2. Check next digit is 8. This is more than 5. Right. So we add 1 to 2, making it 0.073, and that be all, right? That is, so don't get confused. This is a decimal form, and the other one was a whole number, a whole digit, a whole figure. This is decimals. So now let's move to the second one, the second example. We are rounding 231.45. Now, before I even proceed to do anything, just let me clear the air. Looking at this number, 231 is the integral part or the whole part of the number. We have integral part, the whole number. Let me put the whole number or integral part of it. So this is 231. The decimal starts from 4 and 5. So you understand this. So we said that the first one, with the whole number, we consider everything to get the order of size of the number. Decimals, we just truncate and leave them when they are not needed or they are not part of the significant figure. Now, so with that, let's solve the 4 significant figure. So 1 started from non-zero and 2 start. 1, 2, 3. This is 4, right? So this 4, check the next digit. This is 5. So we add 1 to this 4. What do we get? 2, 3, 1. And what? 5. So you realize that we are not adding this one. This one was only used to check. Now let's move to 3 significant figure. Now 1, 2, 3. This is the 3. Now after 1, the next digit is 4. Is 4 less than or greater than or equal to 5? It's less than 5. So what do? We have 2, 3, 1. The integral part is what is important to us. You realize that we didn't bring 0.00. Right, in the first one where you brought 0.00 because the whole thing was integral or whole number. So that's why we needed to add the zeros to give us the order of size of the original number. This is integral. This is a decimal part of it. So we don't worry ourselves there if it's not part of the significant figure. The same thing is applicable when you do the 2 decimal places. It's 2, 3, right? So 2, 3, 1. Sorry, 2 and 3. This is the second significant figure. Check behind is 1. So 1, we have to keep this one. This one is less than that, right? So this one we make it 0. This is the coefficient I was talking about. So 2 and 3. This is 3. Checking behind it is 1. It's not equal or less than that. So we have to keep the 23. Now why did you bring the 0? Because we needed to get the order of the integral part of the whole number. So we have to bring 0. I hope it is understood. If you're still getting confused, in the comment section, let me understand. Right? So that's what I needed to clarify. Right? So the rest of the example will follow in that sense, and it will be convenient. Right? So I think we'll end here, and then if there's anything I need to add, I'll check the next one, and I'll just give a glimpse on that because I'm only left with less than 1 minute. And then the rest of the topic is the same idea. So I'll see you soon. Bye for now.